Welcome to the deep dive. Today, our mission is really zeroing in on what some people are starting to call the LLM 2.0 revolution, specifically for enterprise AI.
Right.
We're looking at a bunch of sources today that aren't just, tweaking the current models. They're really challenging the basic architecture, the benchmarking, everything about the standard systems like your GPTs.
Yeah, it's a really interesting conflict being set up. The main argument basically is that the current way LLM 1.0, built on these massive data sets, trillions of tokens, deep neural networks or DNNs, it's just fundamentally too expensive, too risky, and way too complex for serious professional enterprise work.
Yeah.
You're kind of forcing a generalist tool into a specialist job.
Okay, so let's just frame this with the really bold claim then. The sources we've got, they seem to center on this new generation, and they use a model called xLLM as example. And the goal isn't just making things a bit faster or cheaper.
No, not at all.
It sounds almost like science fiction. They're talking zero weight, no GPUs needed for inference, real-time fine-tuning, and, crucially, genuine explainability linked right back to the source. This isn't just tweaking, it feels like a totally different way of building AI.
Exactly. It's a very deliberate move away from, let's say, general scale no matter what, towards specialized precision you can actually audit.
Right.
And for businesses, think about it. If you jump into AI badly, using these big, opaque LLM 1.0 models, you end up eroding trust upstairs, in the C-suite, because the costs are unpredictable, there's security risks, and these hallucinations, they just create so much operational friction.
Yeah.
If your AI spits out an answer and can't tell you why or where it came from, that's a liability, right? Not an asset.
Okay, so why is that standard LLM architecture, the kind that gives us, surprisingly good consumer chat experiences, why is it apparently so wrong for a business setting? Let's start with maybe how we even measure if they're any good.
Yeah, and this is where the critique of how we benchmark LLM 1.0 gets really, really sharp. The whole evaluation process is seen as flawed because, well, often it uses an LLM as a judge.
Oh, okay. Using an AI to grade another AI.
Exactly. So you're using the system you're testing, or one very much like it, to score the output. It just creates this circular loop where the system kind of congratulates itself. It ends up reflecting the judge AI's own biases and weaknesses.
And the goals are just completely different, aren't they? The sources really hammer this point. What a regular person wants versus what a professional needs from these systems. They're almost opposites.
Totally.
Like if I'm just playing with a chatbot, maybe I want long, kind of flowery answers that sound smart, even if they're making stuff up.
Precisely. The layman often likes that creative conversational style. But a business user, they need short answers, direct source links, high accuracy structure. They want the exact clause from the HR manual, not, a nicely written paragraph about the manual. Standard benchmarks just don't measure that kind of value.
And they miss key features that this LLM 2.0 approach seems built around, like exhaustivity and traceability.
Right. They completely ignore exhaustivity, which is how well does the model find all the little bits of information scattered across maybe millions of documents. And they ignore the quality of things like built-in trustworthiness or relevancy scores.
So like if a specialized model like this xLLM decides a question isn't relevant to the company's data.
It gives a low score, maybe a 1 out of 10. It doesn't just invent an answer to seem helpful. Yeah. But current benchmarks might actually penalize that low score, even though avoiding making things up is exactly what the enterprise needs. It's backwards.
Okay, so the evaluation methods are flawed for enterprise use. Let's look under the hood at the LLM 1.0 architecture itself. We're talking these huge, closed-off, deep neural networks, DNNs, built on billions, trillions maybe, of single tokens. What's the real cost of that design, financially and operationally?
Well, it really boils down to two things: hardware dependency and friction. These DNNs, they need enormous amounts of GPU or TPU power for everything: training, running queries, inference, fine-tuning.
Right, the expensive chips.
The really expensive chips.
Yeah.
And that heavy reliance means sky-high cloud computing bills, huge energy consumption. You're paying massive amounts just to run queries one after another. And then there's the fact that they're black boxes.
Meaning you can't easily see why they give an answer.
Exactly. So you need these dedicated, often very expensive teams doing constant prompt engineering, basically, trying to figure out how to ask the question just right to get a reliable, useful answer out of the black box. That adds massive staff costs and just friction to the whole process.
It really sounds like using a sledgehammer for a task that needs a scalpel. Brute force versus precision. So if LLM 1.0 is all about huge DNNs and single tokens, how does this LLM 2.0 concept, this xLLM, possibly deliver on zero weight and no GPU? That sounds Well, frankly, like marketing fluff. Are we still talking server farms, just different chips?
No, it's a really fundamental architectural split. The base xLLM model, according to these sources, explicitly throws out the standard transformer and deep neural network architecture for its core job.
Whoa, okay. So they ditched the deep learning part.
For the main knowledge retrieval, yes. The source is pretty clear that the speed and efficiency come from not using that deep learning stack for the core indexing and retrieval.
Okay, let's unpack that. If they're not using neural networks for finding the information, what are they using?
They seem to get this super fast performance and in-memory processing by using a proprietary native Python database architecture. It's based on something called nested hashes.
Nested hashes. Isn't that just swapping one kind of black box, a big transformer network, for another kind, like a proprietary database? How do we know that's actually faster when you've got millions of documents?
Well, the analogy they seem to imply helps. Think of the giant DNN like a massive, kind of messy public library. It needs tons of electricity, the GPUs, just to keep the lights on and search the shelves. This nested hash structure sounds more like a company's hyper-organized digital filing cabinet, but one held entirely in memory.
Okay.
Because the system is structured using these predictable, directly addressable hash keys, looking things up is apparently near instantaneous, no matter how complex the query. This kind of structured, predictable access is what lets them ditch the huge, slow training cycles and the need for a GPU farm just to run queries.
Which would mean really fast fine-tuning. If HR updates a policy, you don't need a week-long retraining job.
Exactly. You just update the relevant part of the hash structure, apparently in real time. And that kind of real-time update capability is a massive edge in business. Plus, LLM 2.0 changes the basic unit it works with, instead of the whole internet trained on billions or trillions of single tokens.
Where like total costs of ownership are four separate things.
Right. xLLM uses a much smaller number of multi-tokens.
Multi-tokens.
Yeah.
So like recognizing key company phrases as one single block.
Precisely. For the scale of a company's internal documents, maybe millions of tokens total, but definitely not the trillions on the web, it makes a lot more sense to treat common, complex business terms like total cost of ownership or quarterly earnings report or maybe conflict of interest policy as one single unit, one multi-token. It massively simplifies the processing and keeps the precision much higher.
Okay, that makes sense for corporate jargon. Now, how does this architecture connect to the actual structure of a company? The sources mention a mixture of experts, or MOE model.
Yeah, this is really key for both efficiency and security. It's not designed as one giant, all-knowing brain. Think of it more like a team of super specialized librarians or domain experts.
Right.
You divide the company's knowledge base into domains: HR, finance, legal, marketing, whatever makes sense. Each domain gets its own specialized sub-LLM, its own expert. So when a query comes in, it only goes to the relevant expert.
Which optimizes the answer.
And has huge security benefits, right?
Ah, I see. How so?
Well, that separation inherently boosts security by limiting access. If you're an employee only cleared for HR data, your query only interacts with the HR sub-LLM. It physically prevents you from accidentally or intentionally accessing sensitive financial documents that live over in the finance expert's domain.
Okay, let's shift to the biggest headache for the C-suite with LLM 1.0 hallucinations, making things up. This whole LLM 2.0 architecture seems laser-focused on killing that problem. How does xLLM claim to be hallucination-free?
The absolute key is mandatory transparency, delivered through what they call the structured output. The system gives you two ways to see the answer, but the enterprise way is this structured layer.
Okay, what's the first way, the standard response? Is it just like ChatGPT?
It looks like classic text, yes, but the sources say it's deliberately designed to be much less reworded. It sticks extremely close to the original source text.
Ah, so less chance of it blending sources badly or subtly changing the meaning.
Exactly. It immediately reduces the risk you get when systems heavily rephrase things or try to synthesize multiple, maybe conflicting sources into one smooth but potentially misleading answer.
But the real power for business is in that second layer, the structured output, the audit trail.
Absolutely. This layer, you access it through the user interface. It doesn't just give you text, it gives you proof. It shows these concise, clickable summary boxes, they call them cards. Each card gives you a direct quote or raw extract, plus all the context, the document title, maybe a category, timestamp, the source file, and, crucially, a precise link right back to the exact spot in the original document. You know exactly where every piece of information came from. No guessing.
And the genius seems to be putting scores right there with the answer. A relevancy score and a trustworthiness score. Tell me about the relevancy one first.
So the relevancy score is basically the system's guard against making stuff up.
Hmm.
It explicitly tells the user how relevant that specific summary card is to the question asked, based only on the company's data. So if your prompt is totally off topic for the available document, say, you ask the internal HR expert about, I don't know, quantum physics,
Right.
the score will be super low, like 1 out of 10.
Right.
And that's the mechanism that stops the system from just generating a confident-sounding, completely fabricated answer when the information simply isn't there in the source material. It admits ignorance, which is critical.
And the trustworthiness score, how does that help? Businesses always have conflicting info floating around.
Exactly. That's the age-old problem, isn't it? You've got version 1 and version 2 of the same policy, or maybe different sales figures from different reports. If the system finds the same topic mentioned in 2 different documents, but they conflict, the trustworthiness score acts like an editorial layer. It rates the reliability of the input source itself.
Ah, so it can say this document is more official or recent.
Precisely. It allows the system to basically say, look, source A says X, but source B here, which is signed off by legal and is dated last week, is rated 9 out of 10 for trustworthiness on this topic. So we're prioritizing the answer from source B. It resolves ambiguity based on source credibility.
Okay, one last technical bit before we get to the money side. Exhaustivity. How does a specialized system like this make sure it finds everything relevant, even if someone searches using slightly different company jargon than what's in the documents?
Yeah, this comes down to having better, more tailored text processing specifically for business language. Standard models use very general language understanding. xLLM apparently uses proprietary, high-quality, automatically generated lists of company-specific acronyms and synonyms.
Okay, so it knows the internal lingo.
Right. And importantly, they also use a specialized stemmer and unstemmer.
Okay, for listeners maybe not deep into text processing,
Yeah.
why are stemming and unstemming important here?
Well, think about how people search. If you search for managing project risks, you also want results that talk about risk management in projects or manage project risk, right? Stemming reduces words to their core root, like manage for managing, management, managed.
Got it.
The unstemmer then helps make sure that when the answer is presented, it reconstructs the words correctly, so it's readable, not just root forms. This proprietary approach means the model can find the relevant chunks of knowledge, even if the user's question uses slightly different phrasing or internal slang than the source document itself. It catches more relevant stuff.
This has been a really illuminating look at the architecture and how it tackles risk. So let's connect the dots. What does all this mean for the actual bottom line? The sources keep coming back to total cost of ownership TCO reduction as the main reason for adopting this LLM 2.0 approach.
Yeah, absolutely. If you trace all these architectural differences back to the financial impact, the savings look potentially dramatic, and they start right away with infrastructure, just getting rid of that massive dependency on GPUs that fundamentally cuts power consumption, it slashes cloud bills, and you avoid buying racks of super expensive hardware in the first place.
Huge TCO win right there.
Huge win, even before you look at performance.
And we're not just talking about the one-time cost of training, right? It's the day-to-day cost of running queries, inference. That must be the big one.
Oh, absolutely. The cost per query for calling one of those giant proprietary cloud LLMs can be really prohibitive when you scale it across a whole enterprise. Thousands of employees making queries all day. Because xLLM is supposedly using this efficient in-memory hash architecture, its cost per query should be orders of magnitude lower.
Makes sense.
And on performance, while we said the standard benchmarks are flawed, the sources claim xLLM really shines on ingestion time, how fast it can process and index new documents. That's not usually a benchmark metric, but it's vital for keeping corporate knowledge up to date rapidly.
And thinking about workflow, we talked about prompt engineering earlier. That sounds like a whole category of staff costs that could just evaporate.
Pretty much, yeah. By giving users that better interface, maybe suggesting alternative ways to ask a question based on what's actually in the documents, and especially by providing that structured output with scores and sources, the need for that dedicated team of highly paid specialists just to wrestle answers out of the AI is drastically reduced.
So less training, less operational hassle.
Regular staff can get precise, trustworthy answers much faster without needing to become prompt wizards.
Okay, before we wrap this up, just quickly on security and protecting the company's knowledge, the IP. If this architecture is smaller, maybe more contained, does that make it easier to steal? How does LLM 2.0 stop data walking out the door?
Well, the specialized segmented nature helps security baseline, as we discussed. But the sources also mention some advanced techniques, like something called distillation-resistant watermarking.
Okay, what's that?
It sounds like a way to embed a hidden, very robust digital signature within the model and the data it processes. It's designed to protect the company's intellectual property, both the model itself and the knowledge within it against theft or even against attempts to poison the model with bad data. Apparently, the watermark is so tough that even if someone managed to copy large parts of the model, the ownership could still be proven.
Interesting. And one final point on efficiency distillation. Even if, say, they want a slightly more natural sounding long answer and decide to use a small traditional neural network just for that final output step, the cost stays low.
Correct. That's the final piece of the efficiency puzzle.
Yeah.
If a small DNN is used, maybe just to smooth out the structured output into a more narrative answer, the fact that it only needs to understand the limited, specialized vocabulary of the corporate documents is a massive advantage.
Compared to the whole internet's vocabulary.
Exactly. The required language model is so much smaller and more focused that you can apparently use distillation techniques to shrink the DNN needed by maybe a factor of 1,000 compared to a general purpose one. It's all about using the right size tool, specifically tailored for the enterprise job.
Wow. Okay, this has been a really fascinating deep dive. We've really journeyed from that LLM 1.0 world at, general purpose, huge black box systems that come with high costs and risks, over to this vision of LLM 2.0, specialized, much smaller, explainable, and really engineered from the ground up for PCO efficiency in the enterprise. The whole focus shifts from just predicting the next word to providing traceable, verifiable knowledge.
It does. And, this raises a really important, maybe slightly awkward question for you, the listener, to consider. We've seen how this LLM 2.0 approach is fundamentally engineered to slash total cost of ownership, automating tasks, minimizing infrastructure, specifically getting rid of those huge GPU bills.
But actually realizing those maximum TCO savings often needs someone inside the company, a champion, who's willing to actively cut those budget lines to say, we don't need that giant GPU farm anymore, or these manual review tasks are now redundant.
And that can be politically tricky.
It can run directly counter to how executive performance is often measured, right? Traditionally, success can be tied to the size of your budget, the number of people reporting to you. Bigger is better. So the provocative thought for you is this. In your own organization, look at the incentive structures. Are they actually set up to reward someone for making the kind of radical cost reductions that LM 2.0 seems to enable? Or does that old bigger budget, bigger team equals more importance mindset still dominate how AI adoption decisions are really made?
That's a really powerful question to think about as you evaluate your own company's AI strategy. Thanks for joining us on this deep dive. We definitely encourage you to check out the sources and explore this potential shift further.